6.3, number 35. Mr. Gordon plans to invest $300 at the end of each month in an account that pays 9% compounded monthly. After how many months will the account be worth at least $50,000? Okay. End of the month, so that is ordinary. You have payments of $300. It's a future value because you're building up towards $50,000. And the compounding is monthly. So 12 per year. The time is unknown. So because we're trying to find how many months. So that's the goal here. So what's n? The interest rate is 9%. So it's decimal 0.09, and we need to find the period interest. So we're talking about monthly. So 0.09 divided by 12 is 0.075. So that's the interest per month. Alright, so the future value is the payment times this growth term based on the geometric sum. Okay, what do we know here? So we know future value, we know payment, we know interest rate. You're trying to find the power n inside of here, which is the number of months needed to have the payment accrue collective interest, and when you're adding them all together to sum up to the future value of 50,000. Okay, so what we need to do is peel off all of the terms here. So we need to peel all these successive terms off to get at the n there, which is going to require a logarithm. So first step is divide through by r. That gives the following. Okay. So that's just the growth term, right, from the geometric series. So now multiply through by I to have it cancel there. And so now we're at this. And so add 1 to have those cancel. And now this term is by itself. So we are here. So we want to access the power, so we can use a logarithm. I'm going to first do this with natural log. It doesn't really matter which one you use, but you do want to use one that you can actually easily compute on the next step because you're trying to get a number out. So that allows you to pull the n in front, so you get n times natural log of 1 plus your interest rate equals, oh, need a natural log over on both sides, natural log of future value over payment times interest rate plus 1. Okay, now divide through. So these at this point are numbers because you know all the values, and so you divide through. It'll cancel. So, and then you have an expression for n. So n will equal natural log payment, future value over payment times interest plus 1 over interest 1 plus your interest rate. So that will be 50,000 over 300 times the interest rate, which is 0.0075. Again, you need the monthly interest rate, the period interest rate, plus 1 over natural log of 1 plus the interest rate. Okay, so at this stage, compute them. So 50,000 divided by 300. So this is 166. Again, you want to keep all the decimal points internally here. Then when you multiply 166.66 infinite times the interest rate, you get 1.25. So you have ln of 1.25 plus 1 over ln of 1.0075. So ln of 2.25 over ln 1.0075. So this is what you need to do the computation of. So again, yeah. So it's 0.81. Natural log of 1.0075. 0.074. Again, you want all the decimals. Usually with something like this, it's better to just do these directly. And so you get out of this computation 108. So 108 and then 0.52. So this is asking for how many months until it's at least 50,000. If you did 100, so you can't have a half month compounding here. So what you need to do is round this up so that you have at least enough money there. So it's 109. So 109 months. Alternatively, you can also use log base 10 here. That's something you likely have access to. But you want to, when you're using the log on this step, you want to use one that you can compute easily here to get the value.